Hi, I'm Alessandro Massimo Giordano from DLR. I'm going to present the work named Workspace Fixation for free-floating space robot operations. The scenario is that of a space robot in the moment of capturing or manipulating a target object in orbit. The main goal of this work is to extend the conventional free-floating control strategy, for which the base actuators are completely turned off to save fuel. A limitation of the free-floating strategy is that the system drifts after contact. This is seen in the following experiment. An impulse is given on the end effector of a free-floating robot. After contact, the base starts drifting due to the exchanged momentum. Within few seconds, a singularity is reached. Finally, the end effector task is compromised. The proposed control method is based on an internal-external decomposition for the end effector. The end effector velocity can be decomposed into an internal velocity that is related to the internal joint motion of the mechanism and a locked velocity that is related to the motion of the end effector as part of a unique rigid body. Based on that, the system is transformed into a new space that has a triangular structure. The control is implemented using the new actuator inputs: the net centroidal force, used for the control of the center of mass; the net centroidal torque, used for the extraction of the angular momentum; and the end effector internal wrench, used for the control of the end effector. A hierarchical stability proof is reported in the paper. The proposed internal-external decomposition has a triangular structure in the actuation matrix. The advantage of this triangular structure is that the end effector task is not actuated by the thrusters, but only by the joint torques. This leads to improved efficiency and saturation performance. A second important advantage is that the controller nominally works in free-floating mode. The thrusters are activated automatically only to restore the center of mass after contact, thus limiting the fuel consumption to the minimum needed. Let us now analyze the experimental results for the proposed method. Again, an impulse is given on the end effector, but this time the system is stabilized, thanks to the prompt activation of the thrusters. The controller has been tested for several impulse directions and magnitudes. For all cases, the proposed control method stabilizes the system and keeps a favorable workspace location. In particular, a good manipulability is maintained during all the time. The thrusters restore the proper center of mass location, and the end effector task is accomplished. I'm glad to answer your questions during the interactive session. Please come, and thank you for your attention.